So in this problem, we are asked to find the Laplace transform of the two periodic function. So here the function f of t is two periodic. So it repeats itself every 2 units. And on the interval 0, 2, we have f of t equal 1 for t between 0 and 1, and minus 1 for t between 1 and 2. So basically the graph looks like this. Of course, for Laplace, we only look at the positive side. So, sorry. We only look at the positive side, so the negative side does not matter. So here, so we have 1 and minus 1. And it keeps repeating itself. So this is of course 2, this is 1, this is 2, 3, 4, etc. Okay, so it's a periodic function. So of period 2. So we have two ways. We have we can use a formula that we have seen in a previous problem, which is that the Laplace of f of t, first of all, note that the function is bounded. Okay, so it has Laplace. So for s positive, the Laplace does exist. Okay, so this is um, equal to 1 over, this is a formula for the periodic functions with Laplace, the integral from 0 to 2 e minus st f of t dt. So if we use this formula, we get that Laplace of f of t for s positive, okay, is equal to 1 over 1 minus e minus 2s, the integral from 0 to 1 e minus st dt. Why? Because between 0 and 1, f of t is equal to 1, and minus from 1 to 2 e minus st dt. And the minus because f of t is equal to minus 1 between 1 and 2. So here we have just to compute that two integrals. So the first one, minus 1 over s e minus st between 0 and 1, minus minus 1 over s e minus st between 1 and 2. So putting all the stuff together, we get 1 over 1 minus 2s time minus 1 over s e minus s for t equal 1 plus 1 over s because e minus s0 is 1. And then we have minus, so it's plus 1 over s e minus 2s. And then we have plus minus, three minuses, 1 over s e minus s for 1. So putting the stuff together, we get again the Laplace of f of t is equal to 1 over 1 minus e minus 2s. Okay, we can factor out 1 over s. And this gives me minus 2e minus s plus 1 plus e minus 2s. So we have Laplace of f of t equal 1 minus 2e minus s plus e minus 2s over s time 1 minus e minus 2s. So that is the formula we found by doing by using the formula of Laplace for periodic functions. Now, assume we do not know this formula. So in this case, we need to use the step functions, and we have by using the step functions. So now we use step functions, and we don't use the formula of periodic functions. So we know that f of t using the Heaviside functions, UCs. So it's going to be u0 minus u1 minus u1 minus u2. This describes the function between 0 and 2. And keep repeating this. So this will give us, the next one will be u2 minus u3 minus u3 minus u4, etc., etc. here. So remember that UC is the function C is here, so it's 0 and 1. That's UC of t. So basically, the function can be written as the sum of u2n minus u2n plus 1 of t minus u2n plus 1 minus u2n from 0 to infinity. Or if you want, this will be n from 0 to infinity of u to n minus 2 u to n plus 1 plus u to n. That's the function of t. These uc's are uc's of t. So in other words, we need to put here of t, of t, of t. So now we go for Laplace, and we go symbolically from n equals 0 to infinity of Laplace of u to n minus 2 Laplace u to n plus 1 plus Laplace of u to n. And using the formula for Laplace of uc, we see that Laplace of f of t is sigma from 0 to infinity e minus 2 ns over s minus 2e minus 2n plus 1 s over s plus e minus 2n plus 2s over s. So if we take 1 over s outside, sigma, and then we have e minus 2ns from 0 to infinity, minus 2e minus 2ns minus s, plus e minus 2ns minus 2s. Okay? So this will give us 1 over s, sigma, from n equals 0 to infinity, e minus 2ns time 1 minus 2e minus s plus e minus 2s. Okay, which gives me 1 minus 2e minus s plus e minus 2s over s sigma of e minus 2ns from 0 to infinity. And here we recognize a geometric series, e minus 2s to the power n. And of course, we assume that s is positive, so the series is convergent. And that's how we could switch a lot of things. So, I mean, mathematically speaking, we could have done it as long as s is positive, not equal to 0. So this will give me, by using the sum of a geometric series over 2, 1 over 1 minus e minus 2s. And then, of course, putting the stuff together, we'll find it's not 2, I'm sorry. It's s. we'll find the same formula as we found before.